As part of the unit on scientific measurement, we're going to look at density. So in this set of slides, I need you to look at the definition of density, the formula for it, how to use it, and then what implications we have for the density of a substance. So let's get started. Density is the ratio, which means divide, of the mass of a substance compared to its volume. So the formula that you see here, density equals mass divided by volume, definitely gives us a ratio. Just like in math, when you divide two numbers, that is the ratio as well. Now density is a physical property, and this formula is in your reference tables. So let's look at the units that are used to measure density because it's a derived unit. Now here's what I mean by that. Mass is measured in grams. Volume on the denominator of the equation is measured in a milliliter or a liter or a centimeters cubed. Remember that the conversion that we learned earlier, that 1 milliliter is the same thing as a centimeter cubed, so those units are interchangeable. When you divide grams by milliliters or grams by centimeters cubed, those units don't cancel with one another. So the unit for density is both of those together. And as you look at the bottom of this slide, it's there. Density is measured in grams per milliliter, grams per liter, or grams per centimeter cubed. And the per part of that answer is the divide part of the formula for density. So when you go into lab, how do you measure mass? Well, that one's easy. You measure it with a triple beam balance or an electronic balance. How you measure volume is a little bit different. For a solid, take a look at this setup in lab. If you want to know the volume of that purple rock, you can drop it down in a graduated cylinder to find out. Now on the left side, the original volume of the pink liquid is 7 milliliters. When you drop the purple rock in, the volume goes up to 9 milliliters. If we subtract those two, we find out that the volume of the rock is 2 milliliters. That's called volume displacement. Kind of like when you sit down in a bathtub, the level of the water rises. It's Archimedes' principle. Now here's the density triangle. This is a useful way for you to remember the formula and to know how to rearrange it. So density is mass per unit volume. Again, that per is the divide part, and I've just listed the units there as a reminder for you. Let's work a sample problem. This is already written on your guided notes, so you don't have to copy it down. Think about a good problem-solving strategy. Let's make a list of what we know first. Okay, I know from reading this problem that the mass is 3.1 grams. And I know that the volume is 0.35 centimeters cubed. So the question that I'm being asked is, what is the density of this copper penny? Now that I've made my list, I'm going to plug into that density formula. You can use just the formula if you're really good with the algebra, or if you want to try using the density triangle, it's helpful too. So here's the equation. I'm going to substitute the 3.1 grams for mass and the 0.35 centimeters cubed for volume, like this. And it's just a fraction at this point. Use your calculator and divide. 3.1 grams divided by 0.35 centimeters cubed. The density of this penny is 8.9. See, the units are grams per centimeters cubed. Alright, let's keep going. Why do we care about the density of an object? What difference does it make? Well, the main thing is to know whether an object is going to sink or float. So on the left side of this slide, an object that has a density greater than water will sink. The density of water is 1 gram per centimeter cubed. So this is a picture actually of some cows at the bottom of a pool of water. Cows' density must be greater than 1 because they have sunk. On the other hand, the otter on the right side will float, so his density must be less than that of water. This is true for all substances. If the density of an object is greater than the substance that it's put in, then it will sink. If the density of the object is less than the substance it's put in, then it will float. And that's how you make the prediction. So write down any extra questions that you have. We'll work some more density problems in class, and I'll see you then.